Hello, Sanjay Kumar. I am audible. Please just confirm. You can write in the chat box whether I am audible or not, or you can use your mic also. Okay. Okay, thank you. We'll start within 5 minutes. We'll wait for another participant will join. Okay, now we'll start. Okay, welcome all for today's session. So actually today we'll solve some previous year assignment NPTEL hydraulic engineering. So the first question is the compressibility is the reciprocal of option A bulk modulus of elasticity, shear modulus of elasticity, option C Young's modulus of elasticity, and option D anyone. So please try to write your answer based on your previous understanding about the week 2. You can write your answer in the chat box which option will be correct, whether 1, 2, 3, 4. So please write your answer in the chat box. The compressibility is the reciprocal of. Okay. Sanjay is telling option A will be correct. Okay. Another participant also try to give your answer for question number 1. The compressibility is the reciprocal of. Yes, Sanjay is telling the bulk modulus of elasticity. It is correct. The compressibility is the reciprocal of bulk modulus of elasticity. Now we'll move on the next question. Next question is question number 2. Yes, very important question. Question number 2 is find equivalent head of mercury and the specific gravity of the mercury is given 13.6 for a 10-meter head of water. So here, okay, Mani Kumari also telling A for question number 1. Okay, now we are moving on the question number 2. So here you need to find out the equivalent head of water if you will use the mercury at the place of water. Let's suppose you are measuring something and water is showing 10-meter head. When you will use for measuring similar pressure using the mercury, what will be the pressure head? Whether option A 0.264, 0.354, 0.516 and option D 0.735. Which option will be correct? Please try to calculate and write your answer in the chat box. Please everyone try to calculate the answer for question number 2. Okay, now I want to discuss. Okay, now I want to discuss what is the correct answer for question number 2. So let me calculate. So here question is asking the find the equivalent head of mercury, that is the equivalent head of mercury for a 10-meter head of water. 10-meter head of water means what? That is your pressure. When you will use the pressure, that is the pressure will be same in both cases. When you will measure your head using water as well as mercury, pressure will be same. You are measuring the same pressure, you are going to measure the same pressure. Suppose that a pressure P, when you are measuring pressure P, you get a 10-meter head in a piezometer when you will measuring with water. The same pressure when you will measure with mercury, then what should be the head in the tube? That's why I am written here the pressure in mercury and pressure in H2O will be same. So here rho ZH, that is the head due to mercury when we will mercury, and Hg rho of H2O into Z into head of water. So head of water is given already 10. Here you need to find out 3600, the value is given. Specific gravity is given of mercury is given 13.6. 13.6. So density will be a specific gravity into density of water. So 13,600. Okay. So that's why I've written here 13,600 into 9.81 and head due to mercury. So obviously your G will be cancelled out, and here when you will calculate Hg, the height head due to Hg, it will come, that is your 13.10 divided by 13.6. Now 10 divided by 13.6, it will be, let me just calculate using calculator for exact value, because we need here the up to 3 decimal point. So 10 divided by 13.6, 0.735. So your option D will be correct for this. Your answer will be 0.735 meter. Just imagine the understanding by this question is, when you are measuring a pressure, a particular pressure with water, you need 10 meter or you need more than 10 meter. The height should be of the piezometer more than 10 meter. The same pressure when you will measure with mercury, only the height of your tube is required 0.735 meter. Just imagine. So that's why we measure always the higher pressure with mercury, not water. Remember please always. So we'll move on the next question. Next question is, the paper pulp is an example of pseudoplastic, Newtonian fluid, thixotropic or elastic solid. Just please try to give your answer in the chat box. Okay. Manikumari is telling option number A is correct. Okay. Another participants also please try to give your answer. The paper pulp is an example of pseudoplastic or Newtonian fluid, thixotropic or elastic solid. Yes. So your paper pulp is a pseudoplastic fluid. Actually, it is the shear thinning fluid. Also, we know pseudoplastic as a shear thinning. Shear thinning means what? The or viscosity will reduce as you when the shear rate increase. Remember please, the viscosity will be reduced when the shear rate will increase. So this phenomena is known as shear thinning. This is not related with your time, remember please. So pseudoplastic is this. Pseudoplastic fluid are also called the shear thinning fluid. Example such as paint. When you will just imagine in a bucket, let us suppose in the bucket paint is filled with the bucket. The bucket is filled with paint, and when you will whitewash, when you will paint the wall with the brush, what will happen? You are increasing the shear of the fluid. You are increasing when you will wash like that, you are increasing the shear of the paint, and definitely your viscosity will be reduced. That's why your paint will very clearly, you can just think on that what I am discussing. Like that you can paint your wall. So as you are increasing the shear rate, so your viscosity is decreasing, and you can paint your wall very smoothly and the clear or the pleasantly. Now we'll move on the next question. So another example also you can think like that: blood, paper pulp, we can see, and your milk also, syrup also. We'll move on the question number 4. Question number 4 is: a water tank contains 3-meter deep water. The pressure exerted by the water per meter length of the tank is? Very important question. Option A 28.29 kilonewton, option B 19.28 kilonewton, option C 44.14 kilonewton, and option D 42.26 kilonewton. So please try to give your answer in the chat box for question number 4. So please everyone try to give the answer of question number 4 in the chat box. You have the 2-3 minutes for this question. So it is very simple question. Please try to think, then you can very easily you can calculate. Okay. Sanjay is telling option A, 28.29. Okay, I'm waiting for another response from your side. Okay, Manoj Kumar telling is C, 44.14. Manoj Chakravarti, not Kumar, sorry. And the Mani Kumar is telling option A. Okay, let me solve. So here a water tank, let's suppose just you can think like that, and the water depth is 3 meter. Water depth is 3 meter. The pressure exerted by water per meter length of the tank. So actually here the pressure force we are talking about, because unit is given kilonewton. So here just please think we are talking about the pressure force. So what is pressure force actually? The pressure force is equal to pressure into area. Per meter length is already given, so area is equal to, you can think here area will be your 3 into 1. So what will be the pressure? Now you need to calculate the pressure. So just please, just I will show you. So your pressure force is nothing but that is your pressure is equal to rho g h bar, and rho is 1000, g is 9.81, into h bar is equal to nothing but h by, that is 3 by 2. H is equal to h by 2, so 3 by 2. So now you can very easily calculate. Let me just calculate. 1000 into 9.81 into 1.5. This is 14715. It will be Newton per meter square. And area, now you will multiply with the area here. You will put in this equation I am putting here 14715 into 3. 3 into 1 you can say per kilometer when we are calculating per meter. So that's why I am writing here 1 into 3. So it is 44, oh sorry, 44145 Newton. So in kilonewton, 44.145 kilonewton. So your answer C will be correct. Remember please how you will calculate. Always remember your pressure force will be rho g h bar into area. Pressure force. Now the next question is question number 5. Very important question. Question number 5. The equation of a streamline passing through the origin in a flow field u is equal to cos alpha, v is equal to sin alpha for a constant alpha determined as. So option A is basically you need to calculate the equation of a streamline when u value is given cos alpha and v value is given sin alpha. So which answer will be correct for question number 5, whether A, B, C, D? Option A is y is equal to x cube, B is equal, option B, y is equal to x cot square alpha, and option C, y is equal to x tan alpha, and option D, y is equal to alpha sin x. So please try to calculate. Everyone, important question. This question you can think important for competitive exam point of view also, and conceptual point of view obviously it is important. For question number 5. So you have please another 1 minute. You can write your answer as quickly as possible. Okay, let me solve. Okay, you everyone know please. The equation of a streamline is dx by u and dy by v. So here you need to put the values. dx by cos alpha equal to dy by sin alpha. Just integrate both sides. What you will get? X cos alpha is equal to y sin alpha plus some constant, let's suppose get the c. So for constant and is passing through origin means x is equal to 0 and y is equal to 0. So for calculating your constant, put x is equal to 0 and y is equal to 0. So you will get c is equal to 0. So equation of a streamline passing through origin will be x, that is a, you need to write in the form of y is equal to something. So x sin alpha by cos alpha is equal to y. So your y is equal to x tan alpha. This will be your correct answer. Option number C. Now we'll move on the next question. Next question is question number 6. Very important. A uniform body is 6 meter long, 4 meter wide and 2 meter deep float in water. This is floating in the water. If the depth of immersion is 0.6 meter, depth of immersion is 0.6 meter, then the weight of the body is option A 331.53 kilonewton, option B 233.5 kilonewton, option C 141.264 kilonewton, and option D 37.53 kilonewton. So please everyone try to calculate and write your answer in the chat box. You have for this question around, you can take for 3-4 minutes you can take. So please write your answer. I'm waiting. Question read very carefully and try to, you can draw the diagram also. It will be easier for you. So this type of question you can expect in your final NPTEL exam as well as your competitive exam, and also at gate level you can also think about that, or the question associated with such topic you can think in the gate examination. Okay, Manoj is telling option C. Okay, we'll wait for another participants. Maybe reply. Okay, let me solve. So here question is asking the weight of the body. As per the Archimedes principle, you know all, the weight of okay, the weight of displaced volume of water is equal to weight of the body. This is a very simple line and very clear line. So weight of the displaced volume of water. So you know already this formula. So weight is equal to unit weight, that is rho z. This is rho z. So into volume. This is volume. So here weight of displaced volume of water means rho of water into g into displaced volume. How much displaced volume? How you will calculate? That is the your immersed immersed volume of body. So immersed volume of body how much? So the volume immersed is how much? 6 meter long, 4 meter wide, and the depth of immersion is 0.6. That is 0.6. How much? Let me just so 6 into 4 into 0.6. It will give you 14.4 meter cube. This is the immersed volume of your body. So here 14.4 is equal to weight of the body. So now you can calculate 14.4 into 9.81, or you can take 10 also, and 1000. It will give you 141,264 weight of the body. So in kilonewton, answer in kilonewton. So weight of the body is 141 point, this is in Newton. So for kilonewton you will divide by 1000, 264 kilonewton. So this is the correct answer. So your correct answer is C for question number 6. So hope everyone got it. Now we'll move on the next question. Next question is, okay. The next question, two-dimensional flow field is represented by a potential function. You just remember please, this is the potential function, right? 2x y minus x. This is the given. Phi is equal to 2xy minus x. Determine the value of velocity v at point 3, 2. So the first option is 1, second is B, and option C is 4.12, and option D is 6.7. So please everyone try to give your answer in the chat box for question number 7. Yes, I think Manoj's answer was correct. The previous question, option C. Okay, we'll move. Please everyone try to give your answer within, you can take for this question also 3-4 minutes. Please anyone write your answer, then I can discuss. I'll wait 1 minute more, then after I'll discuss. Okay, let me discuss. Okay, two-dimensional flow field is given 2xy minus x. You need to calculate your value of velocity. That is, you need to calculate this. So what is the value of u? How your potential function is related? d phi by dx, and v is related with d phi by dy. So this is equal to 2x minus 1, and this is equal to your 2y here, not x, and this is your equal to 2x minus 0, so you can write 2x. Okay, so u is equal to 2y minus 1 and v is equal to 2x. At 3 comma 2, your u will be 4, 2 to the 4 minus 1, it will be 3, and v will be 3 to the 6. So here you can put, that is 3 square plus 6 square, that is 9 plus 36, that is 45. So the 49 is the square root of the 7. So here you can go with the option D, that is the 6.7. Let just, yes, option D will be correct for this, for question number 7. So hope everyone got it. Now we'll move on the next question. Next question is about, let me just move. Question number 8. Steady flow, a compressible steady flow of a compressible fluid through a pipe. The density, area and velocity at a particular section are 3.5 kg per meter cube, 2 meter square and 3 meter per second respectively. At another section, the density and area are 2.5 kg per meter cube and 1 meter square respectively. What is the velocity at the section? At the another section we are here. At the another section, that is the next one. So please, option A is 3.5 meter per second, B 8.4, C option is 5 and D option is 5.5 meter per second. Now please you try to write your answer in the chat box. Very easy question. Just think on that, what is given and what is asking. and try to use your basic concept what you have learned in week 2 and your fluid mechanics courses. Now you can write your answer in the chat box. Within 3-4 minutes, please try to calculate. Okay, Manikumar is telling option B. Okay, let me check. Please wait few minutes. I'm waiting for another response. Okay. Manoj is also telling B. Very easy question. Please, other participants also try to calculate. Okay, let me discuss. So, you know already the two section is given. Maybe like that. Section 1 and section 2. At section 1, row 1, A1, V1 is given. At section 2, row 2, A2 given, but you need to calculate V2. So as per the conservation of mass principle, that is your row 1 A1 V1 is equal to row 2 A2 V2, you very easily you can calculate. V2 is equal to V2 is equal to row 1 A1 V1 divided by row 2 A2. Row value is given 3.5, A value is given 2, and velocity is given 3. For section 2, row value is 2.5, area is 1 meter square, and velocity you need to calculate. So okay, we are writing equal to V2. Okay, so here you can very easily calculate. Now, so if you want to calculate, let me just, that is your 3.5 into 6 divided by 2.5, 8.4. Very easy question. Here is V2 is equal to 8.4 meter per second and V1 is equal to 3 meter per second. As we can see here, the area is 2 meter square, and here here area is A2 is 1 meter square. Just you can think, we have reduced area by how much percent? That is a 50%. We have reduced the area by 50%, that is the 2 meter square to 1 meter square, but your velocity increasing by how much percent? Just you can think. That is the 8.4 minus 3 divided by 8.4. From the previous, if you want to calculate, that is 3. Your area is 2 minus 1 divided by 2. So that is 50%. Area is reduced by 50% and your velocity increasing. Let me just, for just your clarification, minus 3 divided by 3. It is increased by 1.8 times, or you can say 1.8 times it is increased. So just you can think how the area and velocity related. Now we'll move on the next question. Next question is very easy question. So an inner tracer is injected continuously from a point in an unsteady flow, in an unsteady flow field. The location of all the tracer particle at an instance of time represent streamline, path line, straight line, and potential line. Which option will be correct? Please try to give your answer. As we have discussed these things in the first week also, so please everyone try to give answer. After this question, I'll take 5 minute break. So if anyone want to take, you can take 5 minute break. Okay, please everyone try to reply this question, and I'm taking 5 minute break. You can also take. Okay, now let us start. So, okay, Manoj is telling option C will be correct for question number 9, and Mani Kumar is telling option B. Okay, let me just, I want to show you the answer. So, we are talking about one tracer insert. So, it means like that, or you can think here. So, we are injecting something from here, and water particle is going like that. And what is the, if this is the color dye you are injecting here, whatever the fluid particle passing from this location, the same color you will appear in the downstream direction. So you will get a line of the colored fluid particles. So that line actually asking the question number 9, and this is known as a streak line. Always remember, please. As I have discussed about the streamline and the path line in the first week, so you please need to revisit the week 1 lecture. So locus of all fluid particle passing through a fixed point at a particular instant of instant is called the streak line. Path line is different. Path line is what? Individual fluid particle. We are talking in path line individual fluid particle how moving. The individual fluid particle line. Remember. So now we'll move on the next question. Question number 10. Okay, here is the definition of a streamline. So please, question number 10 is a streamline is a line, option A, which is normal to the velocity vector at every point, which represent line of constant velocity potential, which is normal to the line of constant stream function. Option D, which is tangential to the velocity vector everywhere at a given instant. So please, for question number 10, everyone try to give the answer. Very theoretical question. So please everyone try to give the answer. So please just read very carefully all the points, all the options, and try to give your answer as quickly as possible. Okay. Option D. Manikumari is telling option D for streamline for question number 10. Another participants also want to give your answer. Okay, this is a very simple question. Question number 10. Streamline is a line, the option D will be correct, which is tangential to the velocity vector everywhere at a given instant of time. So let me just show you the explanation. What? Yes, here you can see the detailed solution. The streamline is an imaginary line or series of imaginary line in a fluid flow field such that a tangent of this line at any point at any instant represent the direction of the instantaneous velocity vector at the point. There is no flow across a streamline. You can remember, please. Now we'll move on the next. So here is the meaning if I want to tell you. If this is your streamline, at every point tangential, give the velocity. Here you can also, when you will draw the tangent, you will give. Here also you will draw the tangent, you will give velocity. Here also if you will draw the tangent, you will give velocity. So like that. At every point, you will give the velocity vector. Now the next question, question number 11. Question number 11 is the depth of center of pressure for a triangular lamina of height h and base b immersed vertically in water with its base at the free surface. The lamina means here you can just think the a body which have the two dimension very large as compared to the third dimension. That is if you will that is the if you want to think the thickness of your triangular is very small compared to your height and base. That's why written lamina here. So now you can just proceed with the question number 11 and try to write your answer in the chat box for question number 11. Okay, for previous question the three student was telling option D. Yes, correct. So please now you try to solve question number 11. Okay, Manoj is telling option C. Okay, I'm waiting for another response also. So please, if you are here joined, so please everyone try to calculate. You sit with pen and paper. It will be benefit for you. Everyone try to calculate whether maybe you get the wrong answer or correct answer doesn't mean, but you need to calculate because here we are discussing, not here is your class or exam. Such kind of thing is not here. So everyone please try to uh, calculate what are the question. Okay, Manikumari is also telling C. Let me draw the diagram. What is question is asking? The depth of center of pressure. Depth of center of pressure for a triangular lamina of height h and base b immersed vertically in water with its base at free surface. You know already the triangle is like that, but base should be above. That is the match with the free surface. So you need to calculate. So you know the that is the center will be h by 3 if this is h and this is b. So here this is b and this is given h. Please everyone try to calculate and your CZ will be h by 3. Now you need to calculate the center of pressure. If I represent with the H star, so you need to calculate this one. And this is a vertically immersed. Here another term you need to know already. Okay. Okay, let me just write the formula. H star will be H bar plus Ig, that is your moment of inertia about your this axis, G axis. Now AH bar, that is H bar is nothing but this one. So let me just show you the answer. So like that, or HC you can also see. Here I have written H bar, but in the solution part HC is written. So your H bar is equal to H by 3 plus your Ig is equal to BH cube by 36 divided by A is half into B into H, that is the area of triangle, into H bar is H by 3. When you will calculate, you will get what? H by 3 plus B cancel out and H square, so only H will be remain, and 3 to the 6 and it will be cancel out, only 6 will be remain, so H by 6, so 3 6, so 2H plus H, so 3H by 6, so you will get H by 2. Your center of pressure, or H star you can say, H by 2. Always remember please. So hope everyone got it. So option A will be correct for this, not C. Now we'll move on the next question. Next question is the question number 12. Question 12 is a perfect incompressible liquid, remember, flowing in continuous stream, the total energy of a particle remain the same. Total energy of a particle remain the same while the particle move from one point to another. This statement is called continuity equation, Bernoulli equation. That is a Bernoulli's concept you can say, not the equation. And the Pascal law or the Archimedes principle. Which option will be correct for question number 12? Just please read very carefully the statement and try to give your answer. Okay, Anurag is telling option B. Okay, I'll wait 1 minute more for another response also. Okay, Mani Kumari is also telling A, B option. Okay, okay, other student please also try to give your answer. We are talking about here the energy, that is the energy conservation. So definitely your Bernoulli equation will be correct based on the conservation of energy. Continuity equation will be based on your conservation of mass, always remember. So now we'll move on the next question. Okay, so the question is in. Now we'll move on the another question. This was NPTEL Hydraulic Engineering NPTEL. This question was from NPTEL 2024. Now I'm going to show you the Hydraulic Engineering NPTEL 2023. Okay. Okay, not visible. Okay. No. Okay. So please, the first question is the atmospheric pressure at sea level is option A 103 kilonewton per meter square, option B 10.3 meter of water, option C 760 mm of mercury, option D all of these. So please think the atmospheric pressure at sea level. Okay, D all of these. Okay. Okay, two student is telling option D will be correct. Yes, option D will be correct. Because always remember please, your the atmospheric pressure at sea level this much Newton per meter square. So in kilonewton this is matching. Of water 10.3 of water means what? Rho g h, that is 1000 into 9.81 into 10.3. So if you will assume this is 10, so what you will get 103.10330. So almost same. And 760 of mm of mercury means what? Rho g h hg. So 1000, not 1000, the rho of mercury hg into 9.81 into 760 mm means you need to convert in meter. So you will get almost this. Let me just check. Oh, I have not. Just go online for calculator. Okay. So 300 into 19.81 into 0.76. Yes, it is coming 101396.16. So it is almost equal. So when you will calculate, this will give also equal to this, almost equal. So all option will be correct. Now we'll move on the next question. Next question is question number 2. The height of water column equivalent to a pressure of 0.2 megapascal is option A 15.38, option B 20.38, option C 25.38, and option D 30.38. The height of water column equivalent to a pressure of 0.2 megapascal. So please try to calculate. Okay. Manoj is telling option B. Anurag is also telling B. Okay, let me calculate. Let me show you. So the height of water column equivalent to a pressure is given 0.2 megapascal. 10 to the power 6 pascal is equal to rho gh. We are talking about water here, so H2O. So 1009.81 into H you need to calculate here. Or if I use capital S, so 0.2 into 10 to the power 6 divided by, or here I want to write at the place of 9.81 10. So it will be easy. 4 is 0 cancel out. So here is only 20 remaining. So it will be 20 point something, because here when you will use 9.81 you will get something fraction. So definitely your option B will be correct. Now we'll move on the next question. Next question is, the liquid used in manometer should have low density, high density, low surface tension, or high surface tension. So just please, this is a general type of question. Based on your understanding you need to give the answer. Here is not just based on your brainstorming you can give the answer. This is not based on a formula and any the concept behind it. But okay, Mani Kumari is telling option C. In the previous questions I have just discussed about it, between the mercury and water. So okay, Manoj Kumar is telling B. Manoj Chakravarti, sorry, and Anurag is also telling B. Okay, other participants also want to give your answer. You can write. I am waiting. I'll wait few seconds. Okay, let me just show you the answer. So here you need to high density. Why? Because of just I have shown you in the previous, just I have just discussed about it. When you will use water for measure a particular pressure, you need much height. When you will use mercury, within a less height you can measure. So always we try to use for measure high pressure, use mercury, that is the high density. The density of water is 1000, you know already, kg per meter cube, and the density of mercury is oh, the density of mercury you know already, 13,600 kg per meter cube. So always we go with this, that is the with higher density. Because of it will you can use very small tube for measuring this, that is the higher pressure. So that's why we use in manometer the higher density liquid. Now we'll move on the next question. Here also the explanation is given. The liquid used in manometer should have high density so that the height of the column can be reduced. Yes, because the manometer are used for high pressure measurement, so it is important to make the column height in a practical limit. Because previously in the question we have used the 15.8 something meter, so it practically not possible 15.8 meter column. Okay, we'll move on the next question. Question number 4. So such type of question we have already solved. A water tank contain 1.5 meter deep. So previously we are solving with the 3 meter. So here is 1.5 meters. So we'll skip this question. Okay. This is your NPTEL 2023. Remember please. Hydraulic engineering. Question number 5 we have already solved. Okay. Next question. This is also we have solved. Previously the dimension was changed only. Okay, please everyone, this is important question. So everyone try to calculate the answer of this question, because this was very important question. So which option will be correct? The question is a uniform body 3 meter long. Let me just erase it. 3 meter long and 2 meter wide, 1 meter deep, float in water. If the depth of immersion is 0.6 meter, then the weight of the body is what? So everyone please try to calculate. For question number, okay, okay, option C, Manoj is telling. So Other participants also try to give your answer. Okay, Manoj telling C. Okay, Sanjay is also telling option C will be correct. Okay, let me just show you the concept. So here the question is asking weight of the body. As per the Archimedes principle, you know already, the volume, that is the weight of displaced volume, the weight of displaced volume of H2O is equal to weight of the body. So you know the formula, this one, the unit weight is weight by volume. So weight is equal to unit weight of something and volume of something. So here unit weight, that is the rho z, and volume of, that is the displaced volume. How much displaced volume? Displaced volume is equal to your immersed volume. 1000 into 9.81 into immersed volume is nothing but, that is the your area, 2 into 1 into depth, immersed depth, 0.6. This will be your weight of the body. Weight of the body. So weight of the body is, let me just calculate, or here I can assume this is 10. So you can think 6 to the 12. Here is 3 into 2. 3 into 2. Okay. So here is 3 to the 6 and 6 36. So around 36. Yes, definitely your, that is a less than 36, because I have assumed here 10. So your, for 9.81 I have used 10, so your answer should be less than 36, not the greater than. So this is coming. So option C will be correct. Now we'll move on the next question. Next question is question number 7. Question 7 is a two-dimensional flow field represented by, oh, we have already solved this. So just please for your, just try to give the answer of this question, question number 7, because the numerical values are changed. So please just for, yes, area will be 3 into 2. I have corrected. So please try to give the answer of question number 7, everyone. So you can expect such type of question in your coming NPTEL assignments. So as you have seen the lots of questions matching from your 2023 to 2024, so you can expect such type of question. Question is matching, the concept is matching, not the exact numerical value is matching. So definitely it will be helpful for your solving the assignments. Okay, Manikumari is telling option D. Okay, Anurag is also telling D. Okay, let me just check. So this is a potential function. Everyone know the potential function is related with the your velocity like that. d phi by dy. So here is your 2y minus 1 and this is your 2y 2x. So add 2 comma 2. So your u will be 2 to the 4 minus 1 3 and v will be that is a 2 to the 4. This is x, remember. So your v is equal to 3 square plus 4 square. So you will get 5. Okay, option D will be correct. Now we'll move on the next question. Next question is question number 8. Okay. This question we have already solved based on your continuity equation. Okay, it's imaginary line. Okay. So everyone please give the answer of this question. Question number 9. The imaginary line drawn in the fluid in such a way that the tangent to any point give the direction of motion at that point is known as. Important question. So please try to give the answer of this question. Question number 9. Read very carefully. Okay. Definitely it will be the streamline. Not B. Okay, yes. A will be correct. Streamline. Now we'll move on the next question. Next question is the streamline. We have already solved this question already. Yes. The pressure less than the atmospheric pressure is known as suction pressure, vacuum pressure, negative gauge pressure, or all of the above. Question number 11. Okay. Manikumari is telling D, all of the above. Please others also try to give your answer. The pressure less than atmospheric pressure we are talking here. Okay, Manoj is also telling D. The other student, please also try to give your answer. Okay, Anurag is telling B, vacuum pressure. Okay, let me just show you the answer. The pressure less than the atmospheric pressure is known as, that is, you suction, you can also say the vacuum pressure as suction pressure and negative gas pressure. So all option will be correct. Next question is, okay, we have already solved this question. So I want to tell you, the question was given previous, in the previous question, that is in previous week, there is a week 1, I have given a question to all of you. I was given this question, that is the angle was 20 degree, and here block was there, and one force was acting horizontally in the horizontally force, and the velocity of the block was 0.8 meter, and this value, the dimension of the block was, let us suppose this was 50 centimeter and this was 30 centimeter, and the coefficient of friction was given mu. We are using, so I'll not write here mu. The coefficient of friction I'll write with a small f. So it was given 0.27, and 2 case was there. The value of f you need to calculate in first case. This was the first case. Second case was there, when we will add, when we will put a thin film of liquid in between your this plane and this body, like that. This is a, let us suppose this is a thin liquid, and this is your body. The everything is same. So this is f. Now you need to calculate, in this case also you need to calculate f2. This is f1 and f2, that is the force in case 2 and force in case 1, everything is same, and you need to find out, and you need to calculate the reduction in force, that is the how much your force reduced when you will apply liquid in between the your plane and body, that is force reduction, reduced percentage if you want to write. So f1 minus f2, force reduction from previous, so that's why I've written here f1. So how you will calculate this f value for first case and second case. So you will proceed with Here just I'll give you hint and we'll discuss in the next class. So here a normal will act between the body and plane. One normal force will be act. That is the force normal I want to write. Force normal. And the weight of the body also act. That is W I will write here. Capital W. And one force will act in this direction. If your block is moving in this direction, so the friction force will act in this direction, F friction. So you know already F friction is your friction factor into Fn. We are solving case 1 first. So you need to calculate F. If this is x direction and this is y direction, so summation of Fx and summation of Fy you need to calculate. So here velocity is uniform velocity, 8 meter per second. So acceleration will be 0. So it will be 0. So summation of Fx, how we will calculate? So in x direction, this force is F. So I am writing this summation of Fx, F. Now in this direction, any force? No. In this direction, force is the friction force. But the direction of friction force is in this direction. But we need to write this component. We need to write this component of your friction factor. So this component is this 20 degree from the horizontal to incline 20 degrees. So from horizontal to incline your degree will be 20. So this is your friction force into cos 20. So opposite direction. So minus F friction force cos 20. Now another also. This is your normal. This is your normal. So for this also you have one component. If this is in this direction, if the angle between your normal and the vertical is 20 degree, already given 20 degree. So the component of this is in this direction. That is one vertical direction. This is Fn cos 20, vertical direction in above direction cos 20, and another in this direction, another will be in this direction, that is Fn cos sin 20, capital Fn sin 20. So another is in this direction, Fn sin 20 degree equal to 0. Summation of Fy will be, similarly you will write for summation of Fy and you will calculate F1 in this case. That is F value in this case. In second case how we will proceed, so we'll discuss on the next day for second case. So please try to calculate. This is a very important question, very important question. Lots of your concept will be clear by these questions. So just for hint I want to give you, at the place of shear force, at the place of your friction force, here shear force will be act, F tau shear force. So your shear force is equal to F tau is equal to shear stress into area. So at the place of your that is shear friction, that is friction force, you will use this value, that is your shear force, and shear stress is equal to, you know already, mu into, if this is very thin, so velocity and the depth, that is the depth of your fluid, and that is velocity already given 0.8, and mu value is already given in the question. So from here the similar way you will calculate and find out your F2, and after that you will compare and you will find out the how much you need to reduce, that is the by how much percentage your force will be reduced. So that's all for today. We'll discuss in the next class more about this question. So everyone please try to calculate. Everyone please. Very important question. So if anybody have any questions you can ask, otherwise we'll, okay. Thank you. Thank you all. So now everyone can leave the class. Okay, thank you. Thank you. Please everyone can leave. Everyone can leave please. Okay. So if you not have I was thinking you have prob questions. So okay. Thank you. Bye. We'll meet in the next class.